Let's say we have to write all the terms in the expansion of 2 plus 3x raised to the power of 4. Now to do this, the first thing we'll do is fall back on a plus b raised to the power of 4, and we know from the formula for binomial expansions that this must equal to the sum from r equals to 0 up to 4 of the product of the binomial coefficient 4r with a to the power of 4 minus r and b raised to the power of r. Now, comparing a plus b raised to the power of 4 to 2 plus 3x raised to the power of 4, we can see that the only difference is the fact that we have replaced a by 2 and b by 3x. Consequently, 2 plus 3x raised to the power of 4 will equal to this sum, this expression, rewritten by replacing a by 2 and b by 3x. And careful, that's all of 3x written in parentheses. Here's what that would look like. It should equal to the sum from r equals to 0 up to 4 of the product of the binomial coefficient 4r and 2 to the power of 4 minus r and 3x written in parentheses raised to the power of r. Now that we've done that, we're ready to write all the terms in this expansion. And for that, we'll need this expression that I'm currently boxing in green. Since this binomial is raised to the power of 4, there will be 4 plus 1, that's 5 terms in this sum, or in this expansion. And each of those 5 terms is obtained using this expression, the one that's boxed in green, and replacing the r we see here by each of the values starting from r equals to 0 all the way up to r equals to 4. In other words, we're going to rewrite this expression for each of the values of r equals to 0, to 1, to 2, to 3, and to 4, and we'll add all of those expressions together. Here's what that would look like. For r equals to 0, that's 0 times 2 to the power of 4 minus 0 times 3x raised to the power of 0. We add to that the case where r equals to 1. That's 1 times 2 to the power of 4 minus 1 times 3x in parentheses raised to the power of 1. We add to that the case where r equals to 2. So that's 2 times 2 to the power of 4 minus 2 times 3x in parentheses raised to the power of 2. We add to that the case when r equals to 3, so that would be 3 times 2 to the power of 4 minus 3 times 3x raised to the power of 3. And finally, we add to that the case where r equals to 4, which would be 4 times 2 to the power of 4 minus 4 times 3x in parentheses raised to the power of 4. Now that we've done that, we can definitely see that indeed we have 5 terms, 1, 2, 3, 4, and 5. And now what we need to do is to simplify this as much as possible. And to do that, one of the first things we can do is to actually simplify all these powers of 2 that we see here. And that would look something like this. Good. Now we can carry on simplifying, and to do that, there's one thing we can keep in mind, which is any number raised to the power of 0 is equal to 1. So this 3x raised to the power of 0 is simply equal to 1. Similarly, on the last term, this 2 to the power of 0 will also equal to 1. Another thing we can use to simplify this a bit is the fact that any number raised to the power of 1 is equal to itself. So this 3x raised to the power of 1 will equal to 3x, and this 2 to the power of 1 will equal to 2. Keeping all of those facts in mind, we can rewrite this sum as Okay, we now carry on simplifying, and to do that, the next thing we can take care of are all these powers of 2, meaning we can actually calculate what their values are. Well, looking at this, we see that we have 2 to the power of 4, and that's equal to 16. We also have a 2 to the power of 3, which is equal to 8, and a 2 to the power of 2, which equals to 4. Using those results, we can now rewrite this in an even simpler form. which looks like this. Okay, the next thing we'll take care of are all these powers of 3x. We have 3x squared, 3x cubed, and 3x raised to the power of 4. And to do that, we need to keep in mind an important rule. Remember, if we have a times x raised to the power of n, then that power distributes across those parentheses so that it equals to a to the power of n times x to the power of n. For instance, if we had 2x raised to the power of 3, then that would equal to 2 to the power of 3 times x to the power of 3. Using that, we can actually go ahead and distribute these powers across these parentheses containing 3x, and that would look like follows. Now, to simplify this further, we still need to calculate these powers of 3 that we have here. We have 3 squared, 3 cubed, and 3 to the power of 4. Now, each of those equals to the following. We have 3 squared, which equals to 9, 3 cubed, which equals to 27, and 3 to the power of 4, which equals to 81. Using those results, this sum now turns into And now the last step before calculating the binomial coefficients, we need to actually calculate these products here. We have 8 times 3, 4 times 9, 2 times 27. So those would be 8 times 3, which is equal to 24. We have 4 times 9, which would equal to 36. And we have 2 times 27, which would equal to 54. So the sum turns into done. We've now gone as far as we possibly could without actually calculating the binomial coefficients. And we can see here that we have 5 binomial coefficients that need to be calculated. But rather than diving onto our calculators and calculating each of these, it's always best to use a couple of tricks. Remember, the first and last binomial coefficient will always equal to 1. Furthermore, the second and second to last binomial coefficient will always equal to the power to which the binomial was raised. So in this case, that would be 4. This tells us that the only binomial coefficient we actually have to calculate is the middle one. That's the 4, 2. And I'll do that in black at the top of the page. The binomial coefficient 4, 2 equals to factorial 4 over factorial 4 minus 2 times factorial 2. That's equal to factorial 4 over factorial 2 times factorial 2, and that's equal to 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Now on the denominator, we see that 2 times 2 equals to 4, which will cancel out with the 4 on the numerator. So we're left with 3 times 2 times 1 on the numerator over 1 times 1. So that's equal to 6 over 1, which is equal to 6. So that middle binomial coefficient equals to 6. We're now left with the last calculations to do, and I'll write the results in red at the bottom. We have 1 times 16, which will equal to 16. We then have 4 times 24, which will equal to 96. We then have 6 times 36, which will equal to 216. We then have 4 times 54, which equals to 216. And finally, we have 1 times 81, which of course equals to 81. Finally, we can write all the terms in this expansion and state that 2 plus 3x raised to the power of 4 is equal to 16 plus 96x plus 216x squared plus 216x cubed plus 81x to the power of 4. And we're done. We've just written all the terms in this expansion using the binomial expansion formula. Okay, everyone, let's quickly move on to the next tutorial in which we solve another typical must-know exercise with binomial expansions.